either that or a single primary key with a prefix, okay? Or to use GUIDs, okay? So whatever. Another thing to do with design, avoid summary tables. Okay, a summary table is like a stock table, which says product number 1, current stock 500. Product number 2, current stock 20. Okay, this is a problem because obviously, if 2 sites are updating the same product, when it comes back up, what do you do? This one says now new stock is 25. This one says it's 24, or they both say it's 25. And actually, you've got to make 24 because they each got one minus 1. Okay, so the best thing, if you're designing it from scratch, is to use a detailed table with a history. Okay, and then you're consolidating it with a primary a stored procedure or a view or just a select statement from your application, whatever is most appropriate. But this is something that makes it a lot easier to replicate. Okay. Beware of large update statements, okay? Because obviously, if you're logging the changes, when you do an update to your client database where there's 20,000 customers, if you do a global update without checking if the field is really needs to be changed, okay? Then your trigger is going to fire 20,000 times and insert a line into your log that basically has no use. Okay, so you want to make a update. Where code different from where field different from whatever. You understand what I'm saying? This is an application level issue that has implications in the logging time. Okay, the time it takes to move from inside the triggers to move to your log table, and performance issues at the replication time. Because obviously, if you're going to be moving the whole log of changes from one server to another server, the more there are, the longer it'll take. Okay. Making small blocks of records. Okay, this means splitting up your replication so that you avoid having to start everything up again if you get broken communication link. Okay, makes sense, but still. The other aspect is that the smaller your blocks are, okay, it makes smaller transaction times, which means you've got less chance of deadlocks. And if you have a large number of sites replicating, okay, bringing data in, taking data out, the more atomic your transaction, your block sizes are, then the better it is. Along the same lines, replicate as often as possible. Okay, even if the customer says 1 hour, great. You know, if there's 1 hour between changes, that's great. Don't. You know, do it every 5 minutes, do it every 15 minutes, because you get lower risk of conflicts. Okay, within 1 hour, lots more people can change the same record than within 5 minutes. Okay, so just by increasing the number of replications that you make, you're going to reduce the risk, the potential risk of there being any conflicts. This also avoids resource spikes. Okay, it means that if you set it to replicate every hour, then every hour your server is going to go, oof, you know, as all the sites start pulling data out of it. Whereas if you do it more regularly, then for starters there'll be smaller amounts of data, and then it'll sort of even itself out better. Better user experience, okay? Because if the customer says every 1 hour is good, but if he gets it every 5 minutes, he's going to be even happier. Yeah, it's obvious. Handling conflicts. So conflicts is a big issue, okay? In any replication, this is maybe the main issue. What happens when 2 remote users change the same record? Okay, what do we do? So what we're trying to educate our users right from the start that for things to run smoothly, the best thing is to set up policies and to build them into the system. Okay. What I mean by policies, I mean, for example, say, okay, this is map out the data that's going to be shared. Say, okay, if the manager, okay, the team manager changes a price on a product, then he's right. Okay, he's right even if somebody else changed it at the same time. Okay, this is just a simple mechanism that you can set up. I mean, a simple policy, And you can build this into your replication system so that if ever any conflicts of this nature appear, they can be resolved automatically by the replicator. Okay? This is good because otherwise, conflicts appear. If they have to be resolved manually all the time, the users they don't enjoy resolving conflicts in the replicator. They don't understand. They have other things to do, like run their business, than doing maintenance for your database application. It's just, they don't, since they don't understand it, they make the wrong response. Okay, the very first application we built that gave rise to our component set, because it became such a nightmare, is that we would actually pop up a window on the users on one of the power users' screens, and we would say, okay, a conflict has appeared. There was about I think 5 remote sites and 1 head office, and we say, okay, what do you want to do? We show this data from the head office, this data from the branch office, which one's right? And you could say half the time they chose the wrong thing, the wrong one. They don't know. They don't know. They don't understand it. You can't expect them to be database administrators and so as a result. But I mean, we were showing it to the user because we didn't know how to resolve it. We couldn't know either. It's 2 sets of data. So yeah, the best thing is to set up policies, okay? And the user can understand this. He can understand if you say 2 people modify something at the same time. Give me the default, behavior that you want. There will always be cases where there's two offices. Okay, neither one of them has superior in hierarchy. So which one should take the? You don't know. Okay. But and also the other issue, okay, in your application itself, you can design it in a way that keeping this in mind, so you can reduce the possibility of conflicts. Okay, yeah, there's different ways of doing that, but just if you have this in mind, it's important. I'm going to go a bit faster now because Jonathan needs to have time, I think. This is a big one. Challenges for setting up trigger-based replication. Record bouncing, okay? Record bouncing means you change it at the branch office, it goes up to head office, gets inserted into the database, but that generates another trigger event. Puts it back into the log, so it goes back down to the other one. It goes up and down, and you wonder what's happening. And, okay, so it has to be set properly to make sure that you know if this is a replication insert or if it's just a user insert from the application. Yeah. Design for resilience. Okay, make it so that you can go on a holiday without taking your phone with you to the beach like this to make sure that the user is going to be able to work properly. Okay, make it so that you can have an enjoyable life as well. Errors must be logged. Databases may be inconsistent. Okay, so this is a bit. Maybe I won't get into all of this right now. But you have to also plan for things going wrong. Okay, connections getting cut off in the wrong moment. Foreign key violations, which means that the insert didn't happen. Users deleting a line before it gets time to get replicated. Okay, this kind of thing. Yeah. Okay, don't blindly replicate the same SQL. Whatever you do in your log file, don't make static, don't insert static SQL pieces of SQL or SQL statements that you're then going to roll back on the remote site, because this will make a mess if ever anything else happens. Okay, so basically your replicator needs to compare at the time when it's replicating the state of both databases. Okay, and it has to tolerate obviously connection loss. Okay, so this is a good time to transition onto our product, because you're probably saying if this is the way you can do a replication, you don't want to do it. We developed these tools because for internal uses only initially, and then a couple years afterwards we posted them on a website. We got some demands, and so we did some custom development for customers. Jonathan will go into the details. I've just got a couple things just to show you. Okay, we developed a set of VCL. Basically, it encapsulates this complexity and makes you able to just define the policies and the rules, set up the links, and then just press go. Okay, we've separated it to allow. Yeah, that's what I just finished saying. It allows you to easily plug in replication capabilities into your software, okay, without having to care about actually how it's implemented. The components take care of trigger creation, log parsing, conflict management, and allow easy personalization via VCL events. Okay, so the proof of how easy this is I was actually able myself, even though he wrote the code, I was able to take these components and build some applications. The replication did that recently. So, good stuff. Okay, there we are. Hand it over to Jonathan for the demo.
Okay, I'd like to present just a simple demo of one of the case studies that we had in Raphael's presentation. So it's the head office, branch office scenario. So the idea is we've got a head office with 2 or more branches. Let's say that the head office is going to be creating the products, setting the prices and stuff like that. All that information has to go down to all the users, all the branches. On the other hand, let's say the head office is also creating customers, but each branch has to see only their own customers. It's a common sort of scenario. So at the head office, they'll create a customer for branch A, they'll create a customer for branch B, but A and B must only see their own customers. On the other hand, they can make changes to their customers, which will go back up to the head, etc. So we have to handle conflicts. And so I'll show you a little bit of how that's done. So I've prepared a demo. I wanted to build it from scratch, but it takes too much time. So I prepared it for you. So it's very simple. Here I have, these are my database connection components. So it's abstract. This means it's you can plug. See, these are using UIB, so for Firebird, but I have ADO, Fib+. I have many different connectivity controls, and you just remove one of these, plug in the other one, and it's all the low-level stuff is handled there. So here we have a connection object, each of my 3 databases: head office, branch A, branch B. Here, these are my dataset controls, which connect to the head office, to the connection controls. And I've simply put a database with 2 tables, customers and products, 3 tabs. Okay, very simple. Yes, this has nothing to do with, this is not necessary for replication. It's just so as to bring the data into a T dataset, and so you can view it in the grids. It's just for the demo. Okay, so then down here we have 3 components which are needed for replication. I'll show you the code afterwards. This is a TCC config object, so that's the control you need for creating the triggers, creating all the metadata that Copycat needs. And I'll show you how that's done in a minute. And then here I have 2 replicator objects. So you can see there's various options and various events. Okay, here we have basically the setup is simple. You have 2 nodes, local and remote. Okay, and here I have a link to my connection object. And here I have to have an identifier to identify which node it is. Okay, I'll show that in more detail in just a second. So that's all. And then we have a few options for how the replication process should work. And more importantly, we have many events because I want to make it as easy to personalize as possible so that your business logic can be totally different from one situation to another without having to redo anything. Okay, so let's just run this and see how it goes. So here, for now, we have 3 blank databases. Okay, and just to show you, there's no replication set up yet. So if I put something here, test, put 50. Okay, it doesn't go anywhere. It just stays at the head office as normal. Okay, so I'll start with a very simple situation. I'll show you how it works, and then I'll show you the code. I press this button, configure head office DB. That means it connects to the database, and it creates the metadata and the triggers it needs. I'll show you in IBX what it's done. Here are my 3 databases. Here I have my customers table, my products table, and here all these RPL dollar tables are created by Copycat for internal use. Okay, and if I look at customers, in the triggers here, I have 3, no, I haven't created for customers. I created triggers for the products table. So I don't have time to show you in detail, but here's the code. Basically, it just puts a line in the RPL log table, which is the table with all my changes, my change log table. I put 1 line for every node, subnode that's defined. Okay. So what we'll start by doing is now we have to define a subnode. What that means is you have to say, for each database, you have to say which other databases you want to send your changes to. For the head office, we want to send it to branch A and to branch B, but for branch A, we have to send it only to the head office, and branch B only to the head office. And of course, once it gets to the head office, it will go back down to branch B. But we have to set up the replication links. So that's done in the RPL users table, which is called users for historical reason. It should be called nodes. Okay, so here we create, so on the head office database, so we'll create branch A and branch B. Commit. So now, from now on, any changes that are made to the products table will be sent down to branch A and branch B. I'll show you that right now. Test 2. So I got a refresh problem now. It's just the data sets not refreshing quickly. Okay, it didn't get. Sorry. It's a little. There. Okay. Now so that's inserted correctly, and it's not replicated yet, but it's in the log for waiting to be replicated. You can see it right here. In the head office database, the RPL log table, in data, we have 2 lines, one for branch A, one for branch B. If we look over here, we'll see, oops, that won't work. Products table, we have the date of operation, and the primary keys value. So with that, we can identify the row, and that's it. Okay.